All right, 5-minute lessons, and we're back. All right, so when you're doing these, they're just going to get a little bit more difficult, but they're all kind of based on a previous concept. It's this idea of solving a simpler problem. So, what you can learn from here, this one you could conceivably put it in your calculator. It's going to tell you 5. Where did that come from? Where, as far as order of operations go, you can consider this the same thing as this. Okay, which is the same thing as this, which gives you that. So what that tells me is we can divide before we apply the square root, if applicable. How does that apply to the second one? Well, 63 divided by 7 is just 9. And then we still have an x. Y cubed divided by y to the first, that's y squared. Okay, so we can simplify that. What's the square root of 9? It's 3. What's the square root of y squared? It's y. And the x remains. So that's how you're going to do that one. Okay, now we'll do one more. So this is the square root of 27. X cubed, just subtracting the exponents. Y squared. Okay, well, we can't completely simplify that, but I can take out a 9, and then that's going to be a 3 on the outside. I can make this x squared times x, and we can bring that x out. So what do we have left in here? We have a 3, and we have an x. Oh, the y squared can go here. So that is your solution on that one, okay? Well, now let's look at how these have a little bit different directions. It says rationalize the denominator. What does that mean? Well, there is a rule in math, not my rule, I don't like it, but we're not allowed to have a radical in the answer. Okay, somebody's rule. So the trick on this is to multiply by 1. That's what I've done here. Keep in mind, I just multiplied by a fancy form of 1. What was the point? Well, on top, I get square root of 5 times y, but on the bottom, you just get a 25. Okay, you guys have done things like this in geometry before. So on this one, well, first I'm going to divide. So let's consider this to be 9. 18 divided by 2 is 9, x squared. But then we're going to have a radical, we cancel that with that, and it'll be a radical y squared in the bottom. Well, we have a radical in the denominator, so what do? We multiply by radical y squared over radical y squared. And what do we have on top? I'll write this answer down here. On top, we have radical 9x squared y squared. And on the bottom, we just have y squared. Oh, we can simplify the top. The square root of 9 is 3. The square root of x squared is x. The square root of y squared is y. So we have 3xy over y squared. Oh, I can go one further. This and that cancels. So we can just call it 3x over y. No radicals in the denominator. We have rationalized it. So look, none of these are inherently easy. It's really important that you check your work on these. Don't try to do too many, but make sure that you're checking to see if the ones you did that you got them correct. Let's see. So now let's see, multiply and then simplify. We should be kind of good at these. The cube roots can be difficult for sure. I don't know. Let's see. Let's start with number 2. Sometimes you want to simplify before you multiply. Sometimes you want to multiply before you simplify. It's just kind of, you'll get better at them as you go. This is just 9, and that's just 6. So we're going to want to write that as 54. Where here, I don't know what the cube root of 45 is. I don't know what the cube root of 75 is. So I think the first thing I'm going to do for this one is just multiply those out. So let's see how I do that. Okay, a perfect time for me to actually show you guys this. This is a little Mr. Crow trick. that involves simplifying things that aren't square roots, although you can use this same trick for square roots. So what I did, if you look over here, is I figured out what 45 times 75 is. Now I'm trying to simplify the cube root of 3375. And this is just, to me, the easiest way to do this. You put your number and you divide it by x to the power of 3. Okay? And then what you're looking for in your table is your biggest list of whole numbers. My table settings on auto, so let me change that back to ask. We're going to start at 1. That's fine. So look here. You only see a very few sets of whole numbers, and there's probably the biggest one, 527. Yep, no more. This is as far as we would ever need to go. So what is that? Oh, 15. We got a perfect cube actually for this one. So that means that this is just a perfect cube. I didn't recognize that. I should have tried that first. So for this one, we're just going to say 15. I should have tried it in my calculator first. If you get to another cube root one and you don't exactly know how to simplify it, come see me and I'll show you how you can get help from your graphic calculator. All right, this should help you get going in 6.2, part 2. Boom!